Oh god, I moved my camera. I need to adjust that. Good morning. It's Wednesday. It's fake Friday because I'm about to get on a plane tomorrow. So, yeah. I hope everyone is having a good week. Let me pull some stuff up. I don't know if there's anyone in chat. It's early on a Wednesday. I don't think this is a peak stream day, but I wanted to cover some stuff before I head out. Yeah. Had, I think, just one pull request. I was still working on some other stuff yesterday, so, and generally preparing. Oh, no, that's the wrong way. Generally preparing to travel. So let's look at that. So if you're watching the VOD, hello in the future. I hope you're having a great future. This PR is one of those ones that I thought was going to be kind of small. I started working on this on the last stream, just kind of sitting down and working on it. And even on the stream, I went back and forth a couple times. And then over the course of yesterday, I kind of went, well, let's back off. Let's take it a step further. Let's take it a step further. But I ended up in a place that I think is better. So I'm excited about that. So we can look at what went on. So before in the past, when we did receive a message and we passed that on to the send raw interface of the NetStack, which is generally used for forwarding messages from an outside interface to either be routed locally or to forward on to another interface, like if we were routing eventually. We would pass both the deserialized header and the raw bytes that made up that header, with the idea that if we were just delivering that, we don't need to reserialize the header because we have the raw bytes. But practically, there's a lot of cases where we would modify that header. Actually, possibly on all interface cases, we would modify the header at least to reduce the TTL, so to decrement the TTL. And I don't generally ever poke raw bytes. I just reserialize. And it's possible it could be unmodified for borrowed sockets. So borrowed sockets work by holding the serialized message. So it's possible if we just delivered it to a local borrowed socket, we could use it, which is why I implemented it there. But in practice, there were a lot of problems where if we didn't reserialize it, which we never were, we would modify the header to decrement the TTL, or for broadcast messages that we're doing flooding, we always update the destination to the next link. So it's kind of like a, instead of just having like a raw, hey, I'm going everywhere message, we actually increment, or we change the destination at each hop. So they were getting out of sync because we would modify the header, but we wouldn't modify the raw bytes. And so initially I was like, oh, okay, well, we'll still pass along the raw header because we might need it sometimes, but then we'll update the header and we'll make it so that it reserializes it. And what I realized is we just shouldn't be doing that. Like, it's too... It's... It added both an optimization and a foot gun to the API. So I decided to just totally walk that back. And so now we don't pass around the raw serialized header anymore. We just pass around the header. And you do have to reserialize it, but the header is max... in the worst case, and it almost never is in this worst case, is 28 bytes. And the amount of time that it takes to reserialize 28 bytes is not a big deal. And we're passing around the header by value in a couple places, which means we're copying a struct that is probably bigger than 28 bytes. And so it just, I don't know, the math wasn't mathin'. So let's look at everything. So the big changes were... and the other thing was send raw. I've kind of been evolving the definition of what send raw should be, but in some recent PRs, I've basically said send raw should only be used by interfaces. And If you are an interface and you're receiving, like you have received a message and you're forwarding it onto the net stack, you always have a header seek. So the difference between header and header seek is that the sequence number is optional in header, because if users pass in a header, they're not in charge of assigning a sequence number, or they're not always, unless they're like replying to something. Whereas any packets that we get over the wire always have a sequence number in them. So send raw now takes a header seek instead of a header. Send raw no longer takes a header raw, and I also removed header raw from a lot of the intermediate plumbing of the net stack. We also have 3 kind of header types, well, 4 kind of, 3.5 header types that we use across the system. There's header, which is usually used by user space, like the users of Ergot. Header seek, which, like I said, is usually used by interfaces, either receiving or sending. They take header seek because packets have to have a sequence number, and the interfaces are in charge of either assigning it or passing on the ones that have already been assigned. And then there's common header, which gets used when we decode a frame. It's the header that both any-all messages have and non-any-all messages have. And then when they do have it, they have what's called an any-all appendix. But header seek actually contains an option any-all appendix anyway. So, yeah. I ended up moving most of the internals of the net stack to use header seek instead of passing along both like a common header and an option any-all appendix. And that way, basically, we've limited these 2 types to more or less just the wireframes module, where we actually do the deserialization or the serialization of this, and the rest of the net stack just uses header or header seek. And I also, there were some intermediate things where I was like, oh, where do I actually do the reserialization of the header and passing along it as raw bytes? And I've basically pushed that down to the interface sync level, which means if we're serializing to a COBS frame, we can do the serialization of the header directly into COBS, and if we're doing it to a non-COBS, we can just do it. And the reason that this is nice is because otherwise we have to serialize it to a non-COBS form and then re-encode the COBS data when we do it. So it's, I don't know which one will actually be faster, but this is just, we've pushed it down to the last minute where we're actually doing serialization of everything else. So I like that. Yeah, so what did this end up looking like? Let me look at the files changed. Let me bump up the font size a bit. So this is just the conformance stuff. We can see that the interface manager send raw takes a header seek instead of a header and a header raw now. Interface sync the same, instead of taking a common header and appendix for the various things. They just all take a header seek now, because at the interface level we have a header seek. Like you have assigned a sequence number by this point. I did rename. In the early days, the interface had an error that was called placeholder oh no, and I think the sockets have an error called what the hell. And these were just my like, hey, I haven't decided whether these are good errors to handle or not, or if these are like internal errors that shouldn't be handled. So I don't think anything was actually using this now anymore. So I renamed it to internal error, because there's at least one place where serialization could fail, but if it does, it means it's like a bug in Ergot. So I renamed that just to reuse the definition. Yeah, DirectEdge, a bunch of these places are gonna work in terms of a header seek now instead of a common header. This is actually a bug, but I fixed it in a follow-up commit. Basically, we get passed in a header, and then we clone it so we can start mutating it, but I use the original one instead of the clone one. But basically, we have some... I was doing in a bunch of places, I was creating a common header just to pass it on, and now we don't have kind of... Like, it was weird, we were changing types for no reason other than we were changing types. So now we're not changing types as much, which is nice. We're not passing on that information. There are still some awkward places where send tie and send error, because they could technically be called by users, they take a header instead of a header seek. So I kind of, there's some awkward places where I have to turn a header seek back into a header. But it's not that big of a deal. It still is a little smelly, but short of having like 2 ways to send errors or 2 ways to send tie, I don't know what to do about that. But yeah, just tweaking some stuff. We can see that, like, I'm not passing the same things anymore. I'm using some built-in methods that I have for convenience. This is mostly just plumbing. This is an interesting part where this is in the actual cob stream. So this is the interface sync. So this is what almost all the interfaces use. They either use a cob stream or a frame stream. And before, we were getting the raw header and we would just insert that. And this is one of those buggy errors or buggy places where we weren't evaluating the updated header. We were just using the original raw header. Excuse me. So instead, when we're allocating space for it, instead of using the exact size of the header, we are using this max encoded size, and we'll run into this in a minute, just to make sure that we have enough room. We serialize into it. We serialize the header now, like we re-serialize the header that we're given. Then we add the body, then we finalize, and then we mark that as ready to send. And the same for the frame stream. We do that. This is basically the same thing. We're just serializing directly instead of cobs serializing. But the same thing. We re-serialize the header here using the max encoded size as the size we're going to use. Yeah, we didn't have a decrement TTL method on header seek, so I added it. It's the same as the regular header method. And then I think the rest of this is just plumbing. This changed the V table of sockets, which is not a huge deal, but it's interesting. Yeah, a lot of the plumbing. Borrowed sockets as well need to re-serialize the header. So borrowed sockets, this is the one place where we maybe might want to have kept header raw, but I decided that I was like, well, if it's enough of a foot gun that I'm removing it from the interface, it's enough of a foot gun that I'm going to remove it from borrowed sockets too. And if we decide that we want to optimize this at some point, cool. But yeah, I guess I am still using what the hell here. But this is one of those things where technically encoding the frame could fail, but this would only happen if our max header encoded size is wrong, which means this practically should never happen. And then I know that this literally will never happen because this finalized method in postcard doesn't fail. So it would fail here instead of here. So this is one kind of hacky thing that I don't love, where to get that maximum size of the header, because I'm not actually like directly serializing the header, because I'm doing this tricky, like I'm using the port as sort of an enum discriminant to decide whether there's going to be an appendix or not. So I kind of manually calculate this, and then I have a unit test, we'll look at it in a second, that verifies this is what we actually get. But we can see this is the max header size of Ergot, and rarely, because a lot of these are varants, a lot of these are rarely actually this size. This only happens if you're sending to like a really high net ID number. Like if your net ID is, well, we'll look at the unit test. If your net ID is really big, but in practice, your net ID is very small, your node ID is very small, and your port is relatively small. So in most cases, this ends up being like 3 bytes. I think in most 2 or 3 bytes in most cases. Somewhere I have a note of what the break points are for this, because this gets serialized as a varant. So like you get 7 bits per byte. So like 0 to OX7F is 1 byte. let me do 2, 3, 4. 1, 2, 3, 1, 2, 3. So that's that. OX, whatever. Whatever 1 to 14 minus 1 hex 3 FFF. So X 0000 80 to OX 00003 FFF is 2 bytes. 121 hex. So OX 000400 to OX. How many is that? That's 001 F FFF. Yes, 4 5 1 2 3 4 5 1 F. Yeah. So this is 3 bytes. And that's easy. OX 2 to OX 7 Fs. So 0 1 2 3 4 bytes. And then OX this is 5 bytes. And so the way this actually breaks apart is these are the port IDs. Then the node IDs are this. And then the upper part is the net ID. So let's see. This means that if we're sending... Actually, this is interesting because it's actually 4 bytes more often than I would have thought, because anytime you're sending over the wire, it's going to be like if you have net ID 1. So actually, a lot of cases, it's just 4. Maybe this is going to make me rethink using varants for this, because actually, I mean, it's 4 bytes. Basically, if you ever have a node ID or a net ID in there, it's going to be 4 bytes, which is less cool than I thought. For some reason, I thought, oh, no. So, I mean, there are a lot of cases. So, if you have a net ID of less than 1F, 31. Okay, so if you have a, so this is basically, yeah, it's fine. Basically, a lot of time, these addresses are going to be 3 bytes, is kind of what I'm saying. Because very rarely, currently, do we have a net ID of bigger than 31. But it's still not actually getting me as much as I would like, which is kind of a bummer. But it's fine for now. So, I mean, a lot of teams, these are 3 bytes. Sequence numbers, if you keep them low, then they'll be 1 or 2 bytes, which is fine. Kind is always 1 byte. TTL is always 1 byte. And then a lot of times we don't have these 13 bytes. Because if you're using a specific destination, although we do have them for like broadcast messages. And a lot of times broadcast messages don't use a name hash, which means this will always be 1 byte. So, I mean, like, on average, a header's probably something like 16 bytes or something like that. There's cases where it'd be more, but yeah, I mean, it's not horrific for a header. I'd have to look at what, like, the IPv4 header is. There's probably more clever ways we could do addresses smarter, but I don't know. I'm not going to optimize that. Are you reinventing varants again? No, just explaining them. Yeah, these are normal postcard varants. So yeah, this is the postcard variant where essentially what you do is in every byte you have 7 bits of data, and then 1 bit that's is this the last byte? So if you're sending 2 bytes of data, you would have, the the lowest 7 bits, then a continuation, then the next 7 bits, and then the end and stuff like this. So this is just what postcard uses for varants. But yeah, so basically I have a unit test that calculates this by basically just setting all the integers to the maximum value. Anything that's an option is a sum, and I just use all the maximum numbers here. And then I just assert in the test that this is still 28. And then I just put some comments in the code that are like, hey, if you touch this, update the max size. So this is kind of manual and gross, but practically it's fine. And yeah, so, and then updating some tests to have that, and then updating some implementations to have that. So that's mostly what this did. My problem with that format is you can't tell how long the number is by just looking at the first byte. Yep, that is a thing. It is what it is, but it is a handy tool for keeping message sizes low. Yeah. Let's see. The other big thing, and then, yeah, there was a pull request that I had where I fixed that bug that I called out, and it was because we had the original header that's coming in that was I header, and then I used to create like a clone called header, and then you can see that I was actually still using the old one instead of the new one where we've modified the new one. So all of a sudden I noticed that I was sending messages without this updated information in it, and the NetStack was upset about that. Rightly so. So I ended up just going, you know what, let's just shadow the value so that we can't make that mistake again. And this is one of those nice things about Rust and shadowing is some people don't like it, but it actually can help avoid bugs if you go, look, I should not be using the old one anymore, so I'm actually going to shadow the value by rebinding a new variable to it. So I do actually think it's a good use case for that. And I changed some panicking asserts. So there's still some asserts in the code base, and I need to fix this because it's not great, but there's some places where I go, if the NetStack shouldn't ever be doing this, I have an assert that fails so that I'll catch it in tests and things like that. But this is not great because data off the network is untrusted, and if someone sends us a bad packet, we shouldn't be panicking. So eventually I need to go clean up a lot of these asserts and either turn them into debug asserts or, graceful error handling, where in this case a router should, if it gets a packet with the network ID of 0, we should not process it as such. But yeah, unless the source is what we expect. So I just went back and fixed this in all the places and shadowed it, so I can't make that mistake again. Then we did a release. So we have 0.11 is out. This is excellent. We had 4 new contributors. So Druskus, 9names, Thomas Kleeny, and Trapich added stuff. So Druskus helped fix some docs. 9names helped improve the CI, and then also added an ESP32 C3 demo. So shout out to Daniel, who's in the chat for ESP32 stuff. Thomas helped me get the log sync implementation working, and then I kind of followed up on that, and so now we can use Ergot as a log sync, and it's also smart enough to, if you're using Ergot as a log sync, Ergot stops using itself as a log sync, so that you don't get that feedback loop of I'm sending messages about sending messages about sending messages. Trapich added the really cool demo for stream visualization, so that's that GUI that we've looked at on a couple streams of looking at doing graphing with eGUI, and and improved some docks and stuff like that. We added some cool pinbox stuff. Then a lot of the stuff for working towards routing, I worked on. That's the biggest thing that I worked on in this release. We fixed that bug that got reported. So really I need to shout out Anwas, who was trying out Ergot and noticed this bug. So shout out to Anwas for doing this. So this again was that if you have two directly connected devices, you have a target and a controller, so the one that's in charge and the one that's not in charge. And the one that was in charge was not being in charge. It was just like, hey, I'm waiting for you to tell me something. And so was the other one. So they were both kind of politely waiting for the other one to start the conversation. And so this changes it so that the controller role starts the conversation and just says, hey, I have a hard-coded ID. Because if we're directly connected, there's only two of us, so let's just talk to each other. What else went into this? And then those fixes that I just showed with the header raw stuff. So those were the big changes. There's a decently large. I really wish we could get the total line changes without cargo lock files, because I think we added a couple of so it's like 10,000 additions and 1,000 deletions. But if we look at like where the biggest ones here are, it's going to be like lock files for new demo projects, I think, are like the biggest diff in all of this. So like if we eventually get to, I mean, this was pretty big. I don't know, this is going to be too many files, isn't it? But yeah, the lock files are adding like multiple thousand at a time, whereas all the rest of the changes are like 20, a couple hundred, a couple single digits. Yeah, you know, it's not huge, but the lock files end up being huge. So our line counts are silly. And if you look at like my line count history of additions and removals, it's like in the hundreds of thousands, and it's almost all lock files. Like I think Ergot is something like 10,000 lines or something now, and that might be including all the demos. So I mean, yeah, I mean, thousands of lines for this. So yeah, well, let's do Tokay. So I mean, Rust, it's 15,000 lines, including the demos and stuff like that. And then if we just go to crates Ergot, and then we do Tokay here. So Ergot itself is like 10,000 lines, which is, you know, not nothing, but it's doing a lot. And there's a lot of the implementations and stuff like that that I may end up breaking out. So like all the profile implementations and things like that. Can I make it do like by folder or something like that? I don't think you can. I think you can do it by file, but if I just do source and I do Tokay dot files, it doesn't give me like per folder summaries, does it? I guess it kind of does, but not super well. Yeah, I don't know. We can see nothing's like huge. None of the files are more than like a couple hundred lines. Like I don't think there are any files that are 1,000 lines, but there's a lot of like 1 to 500 line files, and that adds up. So total's about 9,000 lines of code, which is not nothing, but it's not super crazy. Okay, I think that's everything that's changed since Monday. Today I'm probably not going to be doing a whole lot of coding. I'm probably going to be prepping to leave for the trip and writing my slides. I have an outline now, but I don't have slides, and I'm presenting this weekend, so I should probably have at least a rough draft of my slides before I get on a plane. I guess I have a lot of time on a plane, but I'm not flying first class, so I don't know how much laptop work I'm going to be able to do in in a standard ass plane seat. So I think I'm going to set myself up for success and at least try to have my slides mostly done. So yeah, let's call that a last call for questions or saying hey in chat. We did have a couple people walk in, so it is good to see you all. And like I said, if you're watching this in the VOD later, enjoy. I hope you're enjoying the future. Otherwise, yeah. If I have my slides ready, maybe I'll do a run through tonight. But I'm not going to promise that because I might not yet. Because I got to take care of some other stuff today. But if I do, maybe I'll go over it, or I'll go over the outline or something tonight and see what we have. But yeah, last call for questions in chat. And if not, then I'll drop off the stream. I'm gonna, like I said, I'm gonna try and stream tonight, but we'll play it by ear. If I'm busy, I'm busy. My flight doesn't leave super early tomorrow, so nothing going on. The other cool thing is I had someone, I'll leave them anonymous now, but they said that it was interesting. They have hey Dion, I had someone who said that their customer needed something a lot like Ergot a couple months ago, and they were asking to use Ergot actually. So someone's customer actually was like, hey, can we use Ergot? But to be fair, this was back when Ergot was like way earlier, and it didn't make a ton of sense to use it. So they didn't, and they built their own. And so we were talking yesterday about maybe merging that, but they're close to done with the project. So switching things up now doesn't make a ton of sense, but maybe for the next project. So, yep. I think that's about it. So I'm pretty excited about it. And yeah, hopefully I'll run into lots of cool people. The Rust China schedule got posted finally. There's a lot of cool names on there. So there's a lot of people that I'm excited to see. A lot of people that I've seen before, but so Rebecca Ramble is there. So from the Rust Foundation. See some folks that I know. I know Jack. Jack's a cool guy. Josh Triplett's gonna be there. I know Josh. Hey me. What up? I think I've met Adam before, maybe. I definitely know Habogu. So I think we've chatted a bunch, and so I think we'll have a chance to chat there. Esteban's a very, very cool guy. Excited to see him again. He's one of those people that, like, I talked a lot when Twitter was a thing, and then Esteban went kind of onto Mastodon, which I didn't, and I went on to Blue Sky, so I haven't talked to him very much, but he's a very cool guy. Orhun from Ratatouille, I'm excited to talk to. I don't think I've met Alejandra before. Bart is someone I've worked with in the embedded working group before, so I'm excited to talk to him in China. Rick, I think maybe I've met before. But yeah. A lot of people I've met in passing before at conferences, basically, or like the Rust All Hands and stuff like that. So a lot of people that I have met, a lot of people that I haven't met before, and I'm excited to meet. So if you do happen to be at the conference, please do let me know. Maybe I could bug David Lattimore about maybe doing embedded linker support. That'd be cool. Yeah, I'm excited for it. I think it's going to be a good time. So I'll wrap up with that. Getting ready for the conference, and I will hopefully see you all on stream in the evening. So have an excellent day, everyone.